All right, start recording and share the screen and so forth. All right, so time-wise, we're doing quite well. I'm already starting 1.5, which I originally wasn't going to start until Monday, so I'm a couple of days ahead, and I even had some buffer days to boot. So we only have one more section until the test next week, although it is a very big section, so it'll take me quite a while to develop all that. Okay, so if I have a chance to get ahead and start chapter 2, I will. Okay, and this is where calculus begins in earnest. Okay, now I'll just mention quickly, I saw the survey from you yesterday. Many of you have already had some calculus background. You can't use it, is the way I want to say that. Some of you know some derivative shortcuts. If you never had calculus and you have absolutely no idea what I'm talking about, that's okay. That's actually where I want you to be. Okay, but chapter 2, we're going to be doing a lot of derivatives, so-called. Okay, I know some of you who have no idea what a derivative is. That's fine. The main topic in this course is something called the derivative. After a while, you'll hear me say it over and over and over and over again. Derivative, derivative, derivative. Okay, so those of you with calculus background, you might want to use some shortcuts for the derivative. You can't use any of it for chapter 2. We'll get derivative shortcuts in chapter 3. Okay, so for those of you who had some calculus background, you may not use any shortcuts for chapter 2. And if you have absolutely no idea what I'm talking about, that's fine. That's actually where I want you to be. Okay. All right, so 1.5, we're reviewing now logs, inverse functions, good stuff like that. Okay, so here we go. So 1.5, again, let me show you what the problems are for those of you that don't plan on getting the book. Page 66. So here are some problems. Some more. Try to raise it up here for focusing. 19, okay. Then on the next page, you don't need 20. So there's that, and that, and that, and some problems there. And whoops. Trying to aim it right. Here we are. And some more there. There. Okay. Let's see, some more on the next page. I don't think we have any of these word problems, but you have some of these inverse trig ones. So there. And there. Okay, and that should do it. Okay. Okay, so inverse functions. Okay, so a review of inverse functions, one-to-one functions, and stuff like that. Okay, so on page 56, a one-to-one function never takes the same value twice. They say f of x1 is not equal to f of x2 whenever x1 and x2 are different. Okay, so for a function, 1x can give you only 1y. For a one-to-one function, likewise, 1y can only have 1x that came to it. Okay. That leads to something called the horizontal line test. Okay, now you've heard of the vertical line test for functions. Horizontal line test, okay, a function is one-to-one if and only if no horizontal line intersects the graph more than once. Okay, so the graph of figure 2, and try to get this here. Okay, it's a function. It passes the vertical line test, but it's not a one-to-one function, okay, because there is a particular y value that has two possible values of x. Okay, that means a horizontal line will touch at more than one point. Okay, so that means it's not a one-to-one function, so to speak. Okay, and they give you some examples here. Figure 3, y equals x cubed. See those horizontal lines? That makes it one-to-one. Y equals x squared, figure 4, is not one-to-one. Right? Okay, so it turns out if you have a one-to-one function, you have something called the inverse function. Okay, so one-to-one functions have an inverse function. We write it as f. It looks like f to the negative 1, but it's not an exponent. We read it as f inverse. F inverse. Okay? And f inverse of y equals x means the same thing as f of x equals y. You basically just switch around the x and the y. Okay? So if you have a function with a domain A and range B, just switch around a domain and range. You have the inverse function, f inverse. It looks like f to the negative 1 power, but we say f inverse. Okay? And you just switch around the x and y. So these are equivalent for the inverse function. Okay? So that means on page 57, the domain of one becomes the range of the other. The domain of f inverse is the range of f, and the range of f inverse is the domain of f, because you're just switching around x and y. Okay? And they're emphasizing what I try to say there. Don't think that negative 1 is an exponent. So f inverse of x does not mean 1 over f of x. Okay. So we say f inverse is the inverse function. You just switch around x and y, and you get a new function. Okay. So for instance, f inverse of 7 is 3 means the same thing as f of 3 equals 7. Just switch around x and y. Now, that also means anytime you do a function and it's inverse, you get back to where you started from. Think of an inverse function as an undo operation. Okay, you know how sometimes on your computer you do undo, or a shortcut key might be Control Z, right? That means inverse. Okay, get back to where you were. So f inverse of f, or f of f inverse. We were doing composition of functions, right? F of g, g of f. If you ever do a function and it's inverse, wherever it's defined, then you get back the original x again. Okay. So it's just like cancellation equations. So when you do sine and inverse sine, right? Tangent, inverse tangent. Okay. Exponential, logarithm. So that's what's going on there. Okay. Process for finding the inverse, and I'll do some examples of this, and maybe I'll have you do one of these. Okay, so how do you find the inverse? Well, we said the inverse is just switching around x and y. So you write y equals f of x, switch around x and y, and then resolve for y. Okay? And you write it as f inverse of x, this f to the minus 1 stuff. Okay? And I'll show you how to do that. Okay, and a graphical property of inverse functions. Okay, so here's a function and its inverse. Okay, it does have a reflection property, but it's not a reflection about the x-axis, y-axis, or origin. You reflect across the line y equals x. Okay, so like that. So we look at the blue graph and the red graph, f and f inverse. Okay, the graph of f inverse is obtained by reflecting the graph of f about the line y equals x. Okay, and you can see over here, if you have a comma b, switch them around, you have b comma a. So let's say this is 5, 2, right? The reflection would be 2, 5. That would be over here. Okay, and then a review of logs. Okay, the logarithm function is the inverse of the exponential function. So exponential and log functions are inverses of each other. Okay, you might recall this is a definition of logs. Okay, in case you, if it seems like I'm going fast, I am, but this is all review. In theory, you've seen all this before in intermediate algebra and also pre-calc. Okay, log base b of x equals y means the same thing as b raised to the y equals x. So I like to start with the base. So which is the base? This. The exponent, you go across the equal sign, then you come back in for the result. So b to the y power equals x. So these are equivalent. That arrow means they're equivalent. They mean the same thing. Okay. All right. So since exponential and log functions to the same base, you have to have the same base, both base 2 or base 3 or base e or whatever. Okay. They are inverse functions of each other, which means if we ever do one immediately followed by the other, they cancel each other out. So here are cancellation properties of the log. And this is on page 59. If you want to put it on your formula sheet for the test, you may. Log base b of b to the x equals x for every x in a real number. Okay, so there's a log and an exponential. So they cancel out. And likewise, switch it around. Exponential and then a log. B raised to log base b of x is also equal to x, but that's only for x greater than 0. Okay, you might recall you can only take the logarithm of positive quantities. And I'll show you the graph of that in just a moment. Okay, so these are two cancellation laws. So this is a function and its inverse, the exponential and the log, to the same base. So log base 7 of x and 7 to the x are inverse functions. Okay. For the one that we're going to be doing the most, e to the x and ln x are inverse functions, right? So ln x and e to the x are inverse functions of each other also. That means anytime you have one followed by the other, they cancel each other out. Okay. Okay, page 60. Here's b to the x, log base b of x, and the line y equals x. I'll raise it up just a bit right now so you can see what I'm talking about. Okay, so they're inverse functions of each other, and you can see the reflection across the line y equals x, right? So the exponential function, the blue one, you're probably more familiar with. Okay, take the reflection across the line y equals x, you get the red graph. Okay, and look at the red graph. There's no red graph over here, which means you cannot take the log of a negative number. You also cannot take the log of 0. Okay, so the log functions only define for positive values. And that also makes sense. If you look at the exponential function, right? The domain is all real numbers, which means the range of the log function is all real numbers. Okay, again, the domain of one becomes the range of the other. Okay, look at the exponential again. What's the range? The range is 0 to infinity. That becomes the domain over here. So the domain of the log function is 0 to infinity. Okay, so you cannot take the log of 0 or of negatives. Okay, so just for fun, let me show you. I'm going to hit ln of 0, and I get an error message, right? As I should. Or log means base 10. We're not going to do base 10 very much at all. Okay, and how about I type in -1? Okay, now my calculator actually gives me something. That's a complex number. That means it's of the form a plus bi, but for real numbers, it doesn't exist, right? Okay, so in a nutshell, for real numbers, you cannot take the log of a negative nor of 0. Okay, and here's a bunch of log functions. Okay, so log base 2, log base 3, log base 5, log base 10, and so on. Okay, they all go through the point 1, 0. Well, if you stop and think about it, that makes sense because all of these went through 0, 1. So if you take all their inverses, they all go through 1, 0. Okay. And this time it looks like the log of the bigger base is below. So notice it goes log base 10, log base 5, base 3, base 2. Okay. And then once again, as you pass 1, 0, they switch. Right? So the green is on top here, it's below here. And the lowest one on this side is the black. It's now the largest one on this side. Okay. If you want to put that on your formula sheet, you may. And review of logs. Okay. If you want to put this on your cheat sheet, you may. Number 1, log of a product is the sum of the logs. Log base b of x times y. Log base b of x plus log base b of y. Second one, log of a quotient, log base b of x divided by y, log base b of x minus log base b of y. And number 3, log base b of x to the r power, that r gets to come down in front, r log base b of x. And all of these are both directions. It's not just left to right. You can go right to left also. So some of the homework problems might start off with this and they make you go like that, but you can go the other way too. Maybe it starts off like that and they want you to go this way, or it starts off like that and you go this way, or it starts off like that, in which case you take that r and make it climb back up as an exponent. So be ready to go both directions for these things. Is that right? Okay, then natural log. ln x means log base e of x. So when you have your ln x button on your calculator, the base is e. E is about 2.7, we said. Okay, it's a natural log. It seems like a very funny log, but once we get into the calculus, you'll see that we like base e. We don't like base 10 and base 2 or any other base. Base e is actually going to be our favorite after a while. All right, so based on what we said earlier, page 61, ln x equals y. Remember, that's log base e. It means the same thing as e to the y equals x. Okay. And by the way, another way you can think of this is I can exponentiate both sides, put an e right there and an e right there, e to the y. Then you have e and an ln, they would cancel out. So you have e to the y equals x. Okay. And cancellation laws, we'll be doing a lot of this. Okay. So if you have an equation that has an e, how do you knock it out? With an ln. And if you have an equation that has an ln, how do you knock it out? With an e. So ln and e back to back cancel out. So ln e to the x, that's x. Likewise, e to the ln x is also x. This is true for all real numbers because you can take e to any real number. This one, however, is only valid for x greater than 0 because you can only take the logarithm, we said. Log is only applied to positive quantities. Okay. So among other things, what's useful to know is ln of e. Okay. E is like e to the 1, right? So if you stick a 1 there, ln and e cancel out. So ln of e is 1. Okay. And yeah, natural log of 1 is 0. Log of any base of 1 is 0. Okay. And you can bear that out on a calculator. You can use this type of calculator. So if I try 1 and hit natural log, I get 0. Right? So natural log of 1 is 0. One last thing. Something called the change of base formula. Okay. Log base b of x. You can change it to any base that you want. Our favorite base is going to be ln. So ln x over ln b. So if it says log base 7, you can change it to a natural log. Okay. And if you think in terms of which is higher up, you can put it on your cheat sheet, but if I made you memorize it, the x looks like it's higher than the b, right? See where it says log base b of x? X is slightly higher than the b. So on the right-hand side, the x is above the b, ln x over ln b. And a quick side note, you cannot cancel ln's. Like you might say, okay, I just cross off the ln, say x over b. No, it doesn't work. And the reason why it doesn't work is because it doesn't work. Which means if you try ln x divided by ln b, and you try x over b, in general, you won't see that they're the same thing. Okay, all right. Okay, I think I'm ready to start some stuff. There are some inverse trig. I'll get to that when we, get to the later problems, but I want to get started with some of the problems now. Okay, so getting started on all these problems here, 3 through 12 all, and so on. Okay, now a lot of these are pretty fast. So 3 and 4. A function is given by a table of values. Determine whether it is 1 to 1. Okay, so these are all functions, 1, 2, 3, 4, 5, 6, and then some y value. Okay, they're all functions. What am I looking for 1 to 1? 1 to 1, you're looking for a repetition of y. If any y value is repeated, it's not a 1 to 1 function. Otherwise, it is 1 to 1. Okay, so let's look at number 3. Okay, do you see any y value that's repeated for number 3? 2.0 is repeated, right? Over here and over here. So that means number 3 is not 1 to 1. Not 1 to 1. Okay. How about 4? Are any y values repeated for number 4? Does not look like it. So the answer to number 4 is that it is 1 to 1. Sorry, I can't write this down and hold the book up at the same time. But basically, this one is a no, not 1 to 1. This is a yes. Okay. 5, 6, 7, 8 are very easy. Okay. Are they 1 to 1 functions? You're just looking for the horizontal line test. By the way, 5, 6, 7, 8, do you agree they're all functions, period? 5, 6, 7, 8, they're all functions. They all pass the vertical line test, right? But now we're asking for one-to-one functions. So does it pass the horizontal line test? So 5 is not one-to-one. Okay. How about 6? 6 is a yes. Yes, it is one-to-one. 7? Yes, it's one-to-one. And 8 might be kind of hard to see, but maybe it looks like if I draw a horizontal line right around there, right, it's going to touch again. So 8 is a no, not one-to-one. Okay, so again, quickly, no, yes, yes, no. Okay, then 9, 10, 11, and 12, you have to know something about the function, right? So let's look at 10. X to the 4th minus 16. Okay, x to the 4th goes like x squared, it curves up. And minus 16 just moves it down. Okay, so if it's U-shaped, it is not going to be one-to-one, right? So 10 is a no. 12, cube root of x. Remember what the cube root function looks like? Right? Cube root function, sort of like that. So that one will be a yes. That one is one-to-one, right? Okay. All right, I'll let you try 9 and 11 on your own. Okay, then where are we? 15, 17, 18. Okay, let's look at 15. That should be easy, right? F of 6 equals 17. What is F inverse of 17? You know, if you had absolutely no idea what to do with this, the logical thing would be guess 6, and you're right. Okay, you just switch around the x and y. So I think there's nothing else to say about that one. Okay. 17 is actually kind of weird. G of x is 3 plus x plus e to the x. Find G inverse of 4. Okay, now, you know what G of 4 means. G of 4 means put a 4 right there and right there. But it says G inverse of 4. So I don't put that in for x. I put that in for y, right? So I want y to be 4. And then I plug that in. So let me see if I can do just very little of that. So it looks like this. Okay, take away 1. Whoops. All right. It turns out there's no easy way to solve equations like this. However, fortunately, it's pretty easy to guess. Can you guess a number that would make this work? Guess a real easy number. 0, right? 0 works. So the answer is 0. 0 plus e to the 0 is 0 plus 1 is 1. Okay, but if this were, say, 2, we're stuck. Okay, although we will have techniques later on to show you how to do something like that. But there's no ordinary way, no algebraic or trigonometric or logarithmic way to do a problem like this otherwise. But yeah, it turns out to be 0. Okay. All right, I want to talk about finding an inverse. So I'll show you some problems on finding an inverse, and then I'll probably give you one to do in class, and that'll be it for today. Okay, I'm going to hold off on 18. I'll let you try it, but I'll come back to it tomorrow. Okay, find a formula for the inverse of a function. So 21 to 26. Okay, so how do you find the inverse of a function? So I'll do the even ones. 22, 24, 26, I suppose. Okay. All right. And yeah, let me check the chat real quickly. So, okay. 17 wasn't one of our problems. Okay. Yeah, I think I threw it out, but okay. I just wanted to show it to you anyway. All right. How do you find the inverse of a function? So f of x equals blah, blah, blah. Okay, call it y. Switch around x and y. So every time you see x, put y. Every time you see y, put x. So make that x equals 4y minus 1 over 2y plus 3. So it looks like this. Now, algebraically, solve for y. Okay, so multiply both sides by 2y plus 3. So this becomes 2xy plus 3x equals 4y minus 1. I'm going to try to raise it up for you there. Okay, so now solve for y. So how do you solve for y? Get all the y's on one side and get all the x's on the other. Now, you can solve it with putting all the y's on this side, but I'm going to prefer to have the y's on the right side because I'll have fewer negative symbols. Okay. I notice if I subtract 4y, subtract 3x, I get a negative and a negative on this side. I'd rather have positive, positive, although you get the same answer either way. So I'm going to instead add 1. That's what that arrow there means. I'm going to add 1, and I'm going to subtract 2xy. So it looks like this. 3x plus 1 equals 4y minus 2xy. It just looks a little nicer. Factor out the y. Y equals 4 minus 2x. And divide both sides by 4 minus 2x. Okay, so y equals f inverse of x. I want you to get used to this notation of f inverse of x. F to the minus 1 of x, it looks like, is 3x plus 1 over 4 minus 2x. So this is the inverse function of the original. Okay. This is the undo function. Okay. So what undoes this function is this function. If you ever want to get back to where you were. Okay. Okay, 24 is a little bit tougher. Y equals x squared minus x for x greater than or equal to 1/2. Okay. To solve the problem isn't that big a deal. I'll just mention quickly, why does it say x greater than or equal to 1/2? Okay. What's the shape of this? Parabola. U-shape. You say, wait a minute, parabolas are not one-to-one. That's correct. Okay. However, for x greater than or equal to 1/2, okay, you can show that the vertex occurs when x is 1/2. Okay. So I'll just draw real quickly here off to the side. Okay. If you were to graph this thing, the vertex is down there, so we're just throwing this part out. That part's not really there. Okay. Some of you might remember there's a formula negative b over 2a for the vertex. Don't write that down if you say, I don't remember that. Don't worry about it now. In fact, we'll learn other techniques of getting the vertex. So the only part of the graph is here. So we only have that. It is one-to-one. Okay. Switch around x and y. X equals y squared minus y. Now, normally you can't solve this unless you're able to complete the square. Okay, so remember something called complete the square? Take half the coefficient of y and square it. Okay, so the coefficient is -1, right? So half of -1 is -1/2. This coefficient is -1. Half of it is -1/2. Square it. -1/2 squared is 1/4. That means I add 1/4 to both sides of the equal sign. In red, x plus 1/4, y squared minus y plus 1/4. Okay. The reason why you want to do that is because this will always factor into a perfect square. Okay, so how do you factor y squared minus y plus 1/4? Ignore the square root temporarily. Well, you put the parentheses. It's actually easier than you might think. Just give me the square root of y squared, y. Give me the square root of 1/4, 1/2, and keep this sign. This sign's a minus, I put a minus. If this had been a plus, I would put a plus. Okay, so right now you have x plus 1/4 equals y minus 1/2 squared. Get rid of the square root. Okay. Now, ordinarily you would have to say plus or minus, but not here. The plus is the right side of the parabola, which is what we have. The negative would be the left side of the parabola. Okay, since we're doing the right side of the parabola, I don't have to do plus or minus. So that just becomes y minus a half. Then I have this thing. Finally, you add 1/2 to both sides. So add a half, add a half. So f inverse of x, f to the -1 of x. So 1/2 plus square root of x plus 1/4. And that's the final answer for that one. Okay. Okay, then 26, and that's the last one I was going to do. Then I'll have you do one in class. 1 minus e to the negative x over 1 plus e to the negative x. 26. All right, so call it y. Even if they say f of x, call it y. All right, switch around x and y. So make that an x, make that a y, make that a y. So it looks like this. X equals 1 minus e to the negative y over 1 plus e to the negative y. Solve for y. Oh boy, how do you do that? First, multiply both sides by 1 plus e to the negative y. That's what I mean by that arrow. So the arrow means put that over there. And then I distribute it. So x times 1 is x times that is that. Okay. Now, put all the e to the negative y's on one side and everything else on the other. So I'm going to add e to the negative y on both sides. That's what that arrow means. I'm going to subtract x on both sides. That's what that arrow means. So now I have x e to the negative y plus e to the negative y equals 1 minus x. Okay, factor out e to the negative y. E to the negative y, x plus 1. Divide both sides by x plus 1. But since this started off with 1 minus x, I decided to make it 1 plus x. It's the same thing. It just looks, quote unquote, nicer if I have 1 minus x over 1 plus x as opposed to x plus 1. Okay, so if I divide by x plus 1, it says e to the negative y, e to the negative y equals 1 minus x over 1 plus x. Temporarily ignore the red. Okay, divide both sides by x plus 1. E to the negative y equals 1 minus x over 1 plus x. Okay, and now you might recall, how do I get rid of the e? Take the natural log of both sides, ln both sides. Okay, that way the ln and the e can cross out. That's what that means. Ln and e cross off. So negative y is ln of that stuff, and then it is multiplied by negative 1. Okay, so negative y equals ln 1 minus x over 1 plus x. Multiply both sides by negative 1, and you have it. Okay, so the final answer, or an acceptable final answer, is f inverse of x is negative ln 1 plus x. Oh, sorry, negative ln 1 minus x over 1 plus x. Okay. This is an acceptable final answer, but you could also write it like this. I'll dig deeper. Okay, how did I get this? This is a little bit cleaner because there's fewer negative symbols. Well, one of the properties of logs is you can take that negative 1 coefficient, there's a negative 1, make it come up here, right, as a property of logs. Take the negative 1, bring it up there. So you have blah, blah, blah to the negative 1. Blah, blah, blah to the negative 1 means reciprocal. Then I just flip it. So the best final answer is like that. Okay, I just put the reciprocal of this. This is considered cleaner. It's cleaner because you have one fewer negative sign. That's all. So there we go. All right, so I was going to stop there. I don't see anything in the chat. Does anybody have a question they want to ask real quickly? Otherwise, I'll stop and give you something to do in class right now. And I don't see anything. Okay, so you can put your answer directly in the chat. Please send a private chat again, so you won't just give the answer away. I will type the question in the chat. So I want you to find the inverse. Okay, so I'm going to give you a function. Whoops. F of x is equal to parentheses x plus 10 over 3, and you're supposed to find f inverse of x. Okay? Work it out. Just type it in the chat, send it privately, and then you may leave. Okay? So call it y, switch around x and y, right? And go from there. Okay, I'm going to stop recording.